Okay, the objective of this video, or the point of this video, is to show how to find the sum of the interior angles of a polygon. Okay, and so we'll start out with triangles and we'll move our way up to quadrilaterals, and then maybe we'll show even a pentagon. But this is the sum, as we know, is addition, the total of an addition. And so if you add up all of the angles in a polygon, for example, we have a triangle here. If you add up all these angles, we kind of know this already to be true, that it's going to equal 180 degrees. And also we've already said in previous lessons that a straight angle, or a straight line, is 180 degrees from here over to here. Of course, this would be like a 90, and then if you kept going, it would be 180. And so there's a bunch of different ways to demonstrate this, but one of the more common ways is if we just take a normal triangle, and if we just, as we said, all of these angles should add up to 180. So if we just even willy-nilly tear this triangle, we have one angle of the triangle represented here. And I'll take the other part and I'll just rip this also right here. And so we have this second angle or corner, if I could use that term, of the triangle here. And then we can see that if we add, or if we put the last final corner, you'll notice I'm putting together not the ripped sides, but the original corners of the triangle. They all total up to be 180 degrees. And so we know that for a three-sided polygon, which is a triangle, all of these angles add up to 180 degrees. Okay, now, next we should look at a quadrilateral. Okay, so I have this quadrilateral here, and it's not any specific one. It's not a parallelogram. It's not a trapezoid. None of these angles are equal, but this would work with any quadrilateral. Let's do the same exercise. Just to be clear, I'm going to put a dot in all these corners so you can see that when I line this all up, I'm matching up all four. Oh, maybe you can't see that too well. Okay. These are the original corners of my quadrilateral. So now what I'm going to do is I'm going to tear it just as I did before into four sections so I can put together all of the corners. Okay, so I'm going to take my magnets and see what do all these add up to. Almost looks like 180, but it's not quite, I don't think. Okay, now I can see that all four of the angles in a quadrilateral equal to 180 degrees. 360 is the four sides, 360. The triangle add up to 180, and the quadrilateral add up to 360. Now we kind of knew that a little bit already, because we know that a square has 490 degree angles, or a rectangle also. And so we know that, if a rectangle has 490 degree angles, then that would add up 4 times 90 is 360. But it also works with just with any quadrilateral. All of those angles added up will be 360 degrees. Now, there's another way to represent this this is the same quadrilateral, okay? And instead of tearing it up, what I want to do is I want to show another way to represent this, and that is to cut this from a corner to a corner to make two triangles. Actually, let me go ahead and draw. I'm drawing this. This is, oops. Okay, now, just to be clear, I'm going to call this A and B and C and D. Now, normally, it's probably not drawing this very well because normally that symbol represents that all of these angles are equal. And for this case right here, that's not what I'm trying to do. I'm just trying to show that that was one of the original angles. So don't think of those angles as all being equal. We can obviously see that they're not. But I just want to show you that what I had here was a quadrilateral, and now I'm making it into two triangles. These two A's used to be one solid angle, right? Here, and these two B's used to be one angle, solid angle, whatever. But now I have two triangles, and so I can kind of speculate or also figure out that, well, if I know that one triangle equals 180 degrees, then I know, and I have two triangles here, then I know that, well, both of these triangles, all these angles, if all these angles add up to 180, all these angles add up to 180, then these plus this equals 360. So that's kind of another way of looking at that quadrilateral, is by dividing it up into two triangles. Now, we'll take it one step further to a pentagon. Obviously, this is not a regular pentagon in that the angles and the side lengths are different, but we can still do the same thing. What we can do is, and again, I'll indicate this was an angle and this was an angle. Those were all where the angles were, okay? So what I'm going to do is I'm going to cut this again, and this time, let's see, if I start from one corner, how many triangles I can get out of this. Well, if I cut this here, that gives me one triangle. I'm going to cut it again. And I get two more triangles. So obviously one triangle, I have one triangle. A quadrilateral, I have two triangles. With a pentagon or a five-sided shape, I have three triangles, and so on and so forth. If we were to do a hexagon, okay, this is kind of, if you start at one point. Now it is important that when you're drawing your triangles that you need to start at the same point. You can't, kind of draw as many triangles as you want. Start at one point and see how many triangles you can make. 1, 2, and then 3, 4. So a six-sided shape will give you 4 triangles. A five-sided shape will give you 3 triangles. A four-sided shape will give you 2 triangles. A three-sided shape will give you 1 triangle. And we can see that there's obviously a pattern here. And again, if we had 3 triangles, right, we would have 180 plus 180 plus 180, and I believe that would equal 540. 540, 360 plus 180 is 540. So we kind of see a pattern here. And so if we continue with this pattern, then what we find out is that if S is the number of sides, then S minus 2 times 180 equals the sum of the interior angles. Equals the sum of interior angles. Okay, so in other words, Here we go. Three-sided. Let's see if it works. Three-sided shape. 3 minus 2 is 1, and 1 times 180 is 180. So triangle will add up to 180. For a four-sided shape, 4 minus 2 is 2. 2 times 180 equals 360. For a five-sided shape, 5 minus 2 is 3. 3 times 180 equals 540. And so we can see that this, in fact, does work. And now, last but not least, I wanted to just show you one more addition to this. If you take the same formula, if you're trying to, let's say you're trying to find out, well, how about a regular pentagon? How do I know, how can I make a regular pentagon that has all the side angles, or the side lengths are the same and the angles are all the same? Well, all you need to do is take this formula. If you know that this would be give you the sum of the interior angles, then you divide that by how many sides there are. So in other words, if you have s minus 2, let's say, for example, 5. 5 minus 2 is 3. 3 times 180 is 540. And so if you know that all the angles added up together equals 540, you know there's 5 angles total, then you will get 108 degrees. And so for a regular pentagon where all of the angles are equal, each angle is 108 degrees. It works for any sided shape. If you want to find if it's an irregular shape, then this will give you this will give you the sum of the interior angles. If you want to create a regular shape, this will give you what each of those angles actually are. Okay? So I hope that made sense, and I will see you in the next video.